Linear function review. Recall from Algebra 1 that there are three forms of linear equations. Each one provides us with different but important information about its graph. We have slope-intercept form, y equals mx plus b, so we have the slope, m, how much the line moves, and b, where it begins on the y-axis. If we were to rewrite slope-intercept form in function form, we would have that f of x is equal to mx plus b. The next form of a linear equation is standard form. We have ax plus by equals c, and if we write it in function form, it would be ax plus b times f of x is equal to c. And we also have point slope form. Y minus y1 is equal to m times the quantity x minus x1, where x1 and y1 represent the x and y coordinates from one point that this line passes through. If we were to write this in function form and get it so that f of x is isolated, we would have that f of x minus y1 is equal to m times x minus x1. And then if we were to add y1 to both sides of the equation, we would get this simplified function. F of x is equal to m times the quantity of x minus x1, and then plus y1, that y coordinate from our point at the very end of the equation. We also have lines that are not considered to be functions, and those lines are vertical lines. And a vertical line is not a linear function, as it cannot be written in the form y as a function of x. Instead, it's written as x is equal to the number which correlates to the x coordinate of every single point on this line. A vertical line through the x-intercept of 2, 0 has the equation x is equal to 2. A vertical line through the point -5, 3 has the equation x is equal to -5. A vertical line through some point h, k has the equation x is equal to h. Unlike vertical lines, horizontal lines are indeed functions. A horizontal line is a function as it can be written in the form y is equal to f of x. A horizontal line through the point -5, 3 can be written as y equals 3 or f of x equals 3. Similarly, a horizontal line through the point 0, -2 has the equation y is equal to -2, which can also be rewritten as g of x equals -2. And the horizontal line through hk has the equation y is equal to k, because every single y coordinate has that same k value. Remember that slope-intercept form is the equation of a line written as y is equal to mx plus b, or f of x is equal to mx plus b, where m is the slope, or how the function moves, and b is the y-intercept, or where the function begins on the y-axis. Let's try an exercise. Write an equation of the line AB, given that point A has the coordinate 0, k, and B has the coordinates 3k, -5k. So the first thing that we need to find out about our line is its slope. So the slope of AB is going to be equal to, we have x1, y1, and x2, y2. Remember, slope is rise over run, or y2 minus y1, so -5k minus k over x2 minus x1, 3k minus 0. So we'll end up having -6k in the numerator, and in the denominator we will have 3k. We have a k in both the numerator and denominator, so they will cancel one another out. And then if we divide -6 by +3, it simplifies to be -2. So now we have to find the equation of this line. So we know that in slope-intercept form, it's going to be y equals, we know our m is -2, x, and then plus some b value. Well, we have point A as 0, k. And remember, 0, when it is the first coordinate of a point, whatever that y value is of that point, in this case k, is going to be our y-intercept. So we can fill in k at the end of this equation. If you were to write this in function notation, it would be f of x is equal to negative 2x plus k. Here's the solution to our problem. They also found that the slope of our line is negative 2, and then our b value is k, this y-coordinate that crosses the y-axis. So therefore the equation is y equals negative 2x plus k, or f of x is equal to negative 2x plus k. Here's another example, and in this one we are writing the equation of a line in standard form. Write the equation of the line shown in the coordinate plane in standard form: ax plus by is equal to c. Well, we can see from the graph that from one point to the next we have a rise, 1, 2, 3, and we have a run of 2. Therefore, the slope of this line is going to be 3/2. You could also find this using the slope formula. You end the points 2, 0, and 0, negative 3. So if we did negative 3 minus 0 over 0 minus 2, we would get negative 3 over negative 2, and two negatives, when divided, make a positive. So we still get the same slope of positive 3/2. Now we have to write this in standard form. We do know the y-intercept right here, negative 3. 0, negative 3 is our y-intercept. So if we write the equation in slope-intercept form, it will be y equals 3/2 x minus 3. Now we can convert this into standard form. And in order to do that, let's multiply both sides of our equation by positive 2 to get rid of the fraction that is showing to the right. So we will have that 2y is equal to, and remember we need to distribute the 2 through, 3/2 times 2 will be 3, and then we have minus 6. Now, I usually like solving for my variables on the left, so I'm going to subtract 3x from both sides. And when we do that, we will get negative 3x plus 2y is equal to negative 6. Now, this may appear to be in standard form because it has ax plus by is c. A key feature of the standard form equation is that our a value must be positive. So we need to multiply both sides of our equation by negative 1 in order for the a coefficient to be positive. So that will make our final equation 3x minus 2y is equal to positive 6. And here's the solution to this problem. They still ended up getting 3x minus 2y is equal to 6. Now let's try to find the equation of a line using point-slope form. Remember that point-slope form is y minus y1, which is equal to m times the quantity of x minus x1. Or in function notation, f of x minus y1 is equal to m times the quantity of x minus x1, where m is the slope, and the point, x1, y1, is a point on the line. Here's exercise C. Write an equation of the line AB, given that point A passes through the point k, 2k, and B passes through the point negative 3k, 10k. Well, the first thing that we need to find is the slope of this line. So we have our 2 points, x1, y1, and x2, y2. So we'll do y2, 10k, minus y1 is 2k, all over x2 is negative 3k, minus x1 is just k. Now when we simplify the top, we will end up getting 8k divided by negative 3 minus 1 is negative 4 with a k. Notice that we have a k value in both the numerator and denominator, so they cancel one another out. And then 8 divided by negative 4 is equal to negative 2. Now we can write the equation of our line in point-slope form. So we have y minus we can use this y1, which is 2k, is equal to our slope, -2, times the quantity x minus our x1 that goes with the point 2k as the y-coordinate is just k. If we were to write this in function notation, it would be f of x minus 2k is equal to -2 times the quantity x minus k. Now some of you may be wondering, well, what about point B? Couldn't we write the equation in point slope using point B? We actually can. We would have y minus, this time it would be 10k, is equal to -2, and then in parentheses x minus negative, turns this into a plus sign, 3k. And then if we write this in function notation, it would be f of x minus 10k is equal to -2 times the quantity of x plus 3k. Now some of you may also be wondering, why can I write this equation with this point or this point? Aren't they different lines? No, they are actually the same line. If you were to simplify all of these, they would come out to be the same equation when written in slope-intercept form, making them equivalent linear equations, or equations of the same line. And here's the solution to the example problem. It does show that we can write the equation in multiple forms using both point A and point B as the point showing in the equation. And now that there's more room, I am going to prove that these equations will produce the same linear function. And I'm going to do that by simplifying and solving each of these for y, or f of x. So we have y minus 2k still on the left side, which is equal to, if we distribute this -2 through, we'll get -2x plus 2k. And then if we add 2k to both sides, we'll get that y is equal to -2x plus 4k. And now I'm going to do the same thing with this one. We have y minus 10k is equal to -2x minus 6k. And then if we add 10k to both sides, we'll get that y is equal to -2x plus 4k. So notice we get the same exact equations in slope-intercept form, which makes all 4 of these equations equivalent to one another. Here's another example or exercise. We're going to sketch the graph of the line 2x minus 6y is equal to 10. And remember that 2 points determine a line, so they can be any 2 points. The easiest 2 points to find in this linear equation are the x and y-intercept. Remember, the x-intercept has a y-coordinate of 0. So we can substitute 0 in for y and solve for x. So 2x minus 6 times 0 is equal to 10. Well, 6 times 0 is 0, so we have 2x is equal to 10. So then our x value will be 5. So we have the point 5, 0 that this line will pass through. Now let's figure out our y-intercept. Remember, the y-intercept has an x-coordinate of 0. So 2 times 0 minus 6y is equal to 10. Well, 2 times 0 is 0, so we have -6y is equal to 10. If we divide both sides by -6, we get that y is equal to -5/3 when simplified, which is -1 2/3. So it's a little more than halfway between 1 and 2. And then we can draw a line through these 2 points. And this line represents 2x minus 6y is equal to 10. And here's the solution to our problem. Again, they found the y-intercept to be -5/3, or 0, -5/3, and the x-intercept to be 5, 0. and then they connected those 2 points to make our line. Here's another exercise. Sketch the graph of the equation y plus 3 equals -5 times the quantity of x plus 1 using point-slope form. Well, we know that point-slope form is y minus y1, which is equal to m times the quantity of x minus x1, where m represents our slope and x1, y1 represents our point. So we know right away that our slope is -5. We also know that our point x1, y1 is going to be our point. Now some of you may be saying, oh, this is the point 1, 3. It is not, because we have x plus, which represents x minus a negative. So it's going to be -1, -3 are the coordinates of our point. So we're going to start our graph at the point -1, -3 down here, and we're going to travel in the coordinate plane with a slope of -5. Now that could be rewritten as -5 over +1 or +5 over -1. Both of these fractions simplify to -5. So we're going to actually use this last version to graph our next point because it's easier to go up 5 and to the left 1. 1, 2, 3, 4, 5, 1. And now we can connect our 2 points to make our line. So again, we're starting at the point -1, -3, and then we're rising 5 and going to the left, or in the negative direction, 1. And here's the solution to our graph. We graphed the equation y plus 3 equals -5 times the quantity x plus 1. So the point that we have is -1, -3, and the slope we use to find that second point. We travel up 5 and to the left 1 to make it a negative slope when going from left to right.